Ladies and gentlemen, we would like to present our research at this virtual conference ICIMECE 2020. Our research title is Numerical Analysis of Heat Transfer Improvement in Flat Tube Car Radiator by using TiO2 water nanofluids. This is our research team. We know radiators were an important part in automotive engine cooling system because of the restricted space in front of the engine. Basically, the limited radiator size cannot be enlarged. Hence, the radiator cooling was very important to improve the thermal capability of coolant fluids. This is nanofluids picture. Nanofluids having very superior in the field of heat transfers is a great potential to enhance radiator performance. So this is not coronavirus picture because this is nanoparticle dispersed in the base fluid. Nanofluid was a dispersion of nanoparticles that is currently becoming one of the new breakthrough technologies in heat transfer enhancement. So many literatures have studied nanofluids to enhance the thermal properties of heat transfer liquids. Nanofluid firstly were introduced by Stephen U.S. Choi from Argonne National Laboratory. Nanofluids can be used for ultra-high performance cooling. So, the objectives of our research is two aims. The one is to determine performance evaluation criterion or PEC. The second one is to compare with the numerical findings from the previous published result. This is our numerical procedures. Firstly, we design three-dimensional model on horizontal flat tube performed by using ANSYS. The geometry is length 340 millimeter and 17.6 millimeter in width and 2.5 millimeter in height. Boundary condition on the tube wall is 350 watt per meter square Kelvin. This is the flat tube radiator design as test section geometry. So we can draw in ANSYS design modeler. We design a flat tube for three-dimensional grid configuration. The detail of numerical procedure, number of division is 100, bias factor 20 in axial direction, number of nodes 245,127. This is maximum squeakiness and the average squeakiness. So the operating parameters associated with the numerical study can be listed in this slide. You can see the detail of operating parameters. We use Reynolds number ranging from 130 and until 820. Before running ANSYS program, we use the numerical validation with the established equation. We use the validation of our research two techniques. The one is hydrodynamic validation, and the second one is local Nusselt number. We use at the Reynolds number is 136. So it's clear in the picture our validation is good agreement with the Shah and London equation for the Nusselt number, and it's very good agreement for the Darcy with the Darcy-Weisbach equation. So after the validation, we running program with the others nanoparticle concentration, and we can achieve and can get the result numerical studies. We can show the thermal characteristic in this slide. Nusselt number of nanofluids number with volume concentration of various concentration are lower than that of the water, whereas nanofluids with volume concentration of 3.0% and 5.0% have higher Nusselt number. This phenomenon has similar consistency with the reported result of previous experiment from Aloysius et al. 2017. For to the determine of performance nanofluids in the flat tube radiator, we calculate the performance evaluation criterion. It's clear this picture. Not all performance values are higher than 1.0. It means that adding nanofluids inside a flat tube with the aim of increasing heat transfer does not apply universally. We can say that the thermal performance decreases at volume concentration with the various nanoparticle concentration we use. However, the PEC or performance evaluation criterion values indicates higher than 1.0 at volume concentration 3.0 and 5.0 volume concentration. Finally, we can conclude about our numerical research. The one is Nusselt number of the observed nanofluid enhanced with increasing Reynolds numbers. Second one is Nusselt numbers of TiO2 water nanofluids containing 3.0 and 5.0 volume percent indicate higher than that of water or base fluid. The higher enhancement in thermal consideration might be responsible if compared to the thermal conductivity enhancement. And the fourth one, at laminar flow, the optimum PEC or performance evaluation criterion value of TiO2 water nanofluids flowing through a flat pipe or a flat tube is 1.2845 volume percent and Reynolds number of 136. And the last conclusion of our numerical research, it is still possible to increase the heat transfer performance by adding insert devices which produce a sweet flow in laminar flow regime. This is our research, our numerical research, and we are glad to thanks for the financial assistance in this work by LPPM Universitas 11 Maret through PNPP funding of Hibah Group Research. Thank you for your attention. Good luck.